slide deck that we started last Monday, which is the 26th of October. So that's Monday's things here. Anyway, so what we were talking about is that we're broaching we're talking about a new database system here, which is called NoSQL. It's not SQL, but it's different. And the idea is that when you design your tables, or when you use SQL, you have to keep designing your tables as the data changes. But in the world that we live in, most of the data may come from, say, online sources, or maybe you're in a business where the data just changes like overnight, where suddenly you have a new variable that you have to start collecting and worrying about and analyzing to be successful in your particular industry or your research. And so if you're collecting that data and keeping it in an SQL type database, then you have to go back to your schema and to reorganize the schema. You'll have to continually to go back and redesign things, and that just becomes very tiresome because you have to be developing something that's already been developed. It's kind of like if you build a building and then you have to keep going back and adding additions to the building depending on the kinds of, I guess, the economic culture that the building is being used in. You have to redesign or give it a facelift every period of time. So what we're talking about here is a database schema that has to be continually redeveloped. And another thing that's actually kind of difficult is that when you redevelop your database, supposing, for instance, that you add this the original database at first, last, and primary, and the primary columns, but then suddenly we add the second and third attributes here, the second address and third address attributes. Well, the thing is, though, that for all the data that we collected before those were added, we'll have blank spots in our table, and that means that we have a table that really looks kind of like this, where we have holes in our data, we have columns. When you add a column in, you're actually adding a column to the table, and so all the data that you collected before that column was added is going to have blanks in that column, and so you'll have all this basically space allocated for nothing, and so you'll have a table that looks like this, where it's just filled with holes, and so you have a bunch of empty space, and that's actually a bad thing when it comes to SQL, because that means that you have to control, or you have to manage that memory in your computer, but you also have just this giant database now, which doesn't have much data in it, but you still have enough. Each of these entries here, these places, still has to be kind of, I guess, searched, if you will, by the database's search mechanisms when you run a query, even though there's nothing there. And so it does provide some kind of slowdown to your database. So the big question that we asked ourselves is, what can we do about this crazy system here? Well, we can use a different type of system called MongoDB, which is actually classified as a NoSQL, or not only SQL, which means that it does everything that an SQL database would have done. However, it doesn't need to have a schema developed every time you change something. You don't have to redevelop your schema. In other words, as the data is coming over, as you're adding information into or populating your database, then provided that you add, or that you're sending this data through in the right kind of format, like using it, in this case, using a JSON file or JSON format, which we'll talk about. But provided that you send your data through like that, then Mongo should be able to pick up the data and then create the schema on the fly. So one thing, and I know that I'm going through this rather quickly, we have actually covered these slides before, so I don't mean to confuse anybody, but I just wanted to kind of get us all kind of caught up to where we were. We have new vocabulary that we have to worry about now, and I would say out of this list, the most important thing that we have to know is the table, which we called them tables before in SQL, but now in MongoDB we call them collections, which is sometimes hard to swallow, because when you first hear that word collection, I think, what are you referring to? I mean, I think of, I guess in this case, though, a collection is meaning like it's a collection of all the data that's related in this system. Typically in Mongo databases, though, you tend to have like one giant table with just different rows, or different, what they call, documents. And by that, I'm saying that you have everything kind of like dumped together into one huge JSON file, and then you just enter that JSON file into Mongo, and then you let Mongo's search algorithms and parsing capabilities find the actual information that you're looking for. And so it becomes actually kind of a more simplistic database to run if you don't have to worry about the schema, but also though you don't have to worry about ensuring that there's a different table for every piece of information. And I guess also what that translates to in a very real sense is that you don't have to worry so much about the tight relationships which exist between all the data. In other words, you can just collect information as it's coming across online, and just throw it into a row, which is what they call the document. The row is going to be like your information, which might concern, I don't know, each user. So for instance, if I have a database where I'm keeping track of the users who log into my website, I might need to know their name, their login name. I need to know what their encrypted password is. Maybe there's a photo someplace in there. Maybe their last login, that kind of information. I would store all that information into that user's row. So that means that all the information about that person is now collected into a part of the entire collection, the entire table. Yeah, so it's kind of a strange thing here. But what I mean by that is, like, you can see that this is the schema, if you can call it schema. This is the schema that Mongo uses, where, for instance, you just have to define words on the left-hand side, so age, or name, age, status, and groups. And on the right-hand side, you have strings and arrays and characters and integers, and even floating points if you want, where you're storing information. And what Mongo does when you write a query is it's going to go through that collection, the whole collection. It goes through everything. And the search that you type in, if you're looking for age, then everywhere that the word age exists in the collection, if there's a number that follows that, it will report that number. And so it's a basic, I guess, parsing operation. And by parsing, what I'm talking about there is that you're going through a body of text and you're pulling out information according to certain types of words which exist in your collection. So it's a parsing operation. And so for that reason, you don't need a schema, and you don't need to worry about the same types of relationships that we had before. In fact, the data that you store in this thing could seemingly be unrelated to each other, but you can still locate it because each piece of information has some kind of an attribute, or an attribute here. You'd call this as an index, or basically call it a place where you put it, like maybe a field where you actually store the information. So anyway, you'll see what I mean. This is another thing that I spent some time talking about. I didn't actually mention that this is probably one of the best examples of what data looks like when it goes through Mongo. Because here you can see that there's, these are all different, going back to our thing here, they're all different collections that we have, or this one, they're all different rows that we have here, if you will. Each of these boxes, if you will, is a different row where it concerns a different person. So the first one concerns the person named Will. The next one going to the right, contains the person named Jeff, then Brandon, then Ben, then Matt. And so these are your so-called rows, or you'd have them as your, going back over here, you'd have them as your documents. And I guess that's why they call them documents, because each of these things is kind of a document in its way. It looks kind of like a piece of paper with stuff written on it. But what you're doing now is that when you have information for something, when you have, like, for instance, I'm looking at the piece of information here that's pizza. For the name Matt, on the lower right-hand side, you have this attribute, let's call it the attribute, a field for pizza, Sigorno. And it seems that nobody else has pizza listed in their document. What a piece of information that is. So what I'm saying is that if you have this information, then you can just go ahead and add it to the document. But if you don't, then you just don't add it. But you can see how, for instance, if you're running a query-based search mechanism, or if your algorithm is kind of a search, or it searches for text, then wherever you have the word pizza is wherever that search is going to work. So for instance, here, if I type in, give me all the references to pizza across this entire collection, it's going to find the document for Matt and say, the pizza I found was for Digorno. And so that's kind of how it works. If this were an SQL table, it would be kind of a nightmare because I would need a table that has name, eyes, birthplace, aliases, location, boss, hat. I'm looking at for Ben. I need pizza. I need height, and I would need. That's it. So I need to have a giant table with a column for each one of these attributes that I see, so that I can collect this information. That all the information that I see here. And in many cases, like for instance for pizza, there's that information is missing. And so now my database has to manage an entire part of the database reserved just for storing pizza information, in which there's really not much information to store. So anyway, I'm digressing here a little bit here. I didn't want to spend so much time, but I think this is actually fascinating. I think that Mongo is a really fascinating system here. And if you look at the code to see how it works, it's just magic. I mean, it's not magic, but I mean, it works magically. It's a very inspired, I would say, database. But here, though, you can see kind of like how the data is organized. This would be your document where you'd have, for instance, the name of R2D2. That's one piece of information. The next piece of information is droid, and the next piece of information after that is rebels. And so you're able just to kind of like start adding information between these brackets here, these curly braces, not brackets. You're able to like put information between those curly braces. But if you're familiar with JSON files, this is a JSON file. A JSON file is characterized by something that looks exactly like this, where you have curly braces, then you have some word, some piece of vocabulary, some identifier, then you have a colon, and then you have something that follows it. And so this is a JSON file. And so the magic behind Mongo is that it uses JSON files to store its information internally. And then that's how you actually add information, which actually works out very nicely because when you work with data, if you download data from many database sites, they actually do provide that data to you in CSV form or comma separated variable form, or you can get the data as a JSON file. And that means that if you have the data as a JSON file, then there is nothing stopping you from just dumping this data or just pasting it into Mongo, and it's good to go. Now, before I go too far here, let's not forget these operations called the CRUD operations, or the create, read, update, and delete. Every database must have these commands. It must have some equivalent commands for creating, reading, updating, and deleting. If you don't have that, then that means your database is incomplete. So every database that you're working, if some software calls itself a database, you have to be able to create the data. That means to actually add data, populate your database. And then you should have the capability to actually read that data, which means to find, to query data, to find particular types of data in that database. I mean, not everything, but actually to go after specific parts of the data. Then you have an update command where you can change the data. You can actually take something out, put something in, and then save it. And then you can actually delete things where you actually remove something completely, so it's just gone. And so that is the characteristic of a database. Now, this brings me to where we left off before, and I didn't mean to take all this time to discuss all this, but I did want everyone to kind of get caught up. I know that as we go through our semester, as we go through our week here, it just seems like everything runs together. Is it just me, or is it just me? Everything just runs together. Yeah. So anyway, but so then I wanted everyone to get caught up on the cool, fun, magical amazement of Mongo. Cool. So anyway, what we did is we began using Docker to run Mongo. You can actually install Mongo if you want locally on your machine, but I use Docker for Mongo because it just makes everything much easier to install. So what I did last time was I've already installed Docker on my machine, but I typed in this command here, and then I used Docker to install Mongo. If you don't have Docker installed, it's not going to work, but you have to have it, once it's installed and it's working, then this should work just fine. And then, so this first command here kind of like creates the files that you need to have. In fact, this works for Windows. If you're working with Mac or an OS, or so Mac or Linux OS, then you'd use sudo, I think, and that gives you the super user privileges. Otherwise, I think in Windows, you just need this. And one thing I will say, and I didn't write them in my slides, which I should have done, I think I wrote them in the next slide here. You want to use the PowerShell when you're running Docker commands. I'm getting that from my colleagues in here. Is that right?
I got it too.
Okay, so command prompt does work, and okay. So it seems like it works less. So the consensus here is that it does work when you are using your command prompt, and it also works with PowerShell. So I guess the moral of the story is to use whichever one you feel more comfortable using. If one doesn't work, try the other. Anyway, I mean, you can let me know. I mean, if you find that the PowerShell works better than command prompt, then let me know what you find. I'm interested to hear. Anyway, but still, when I tried these out, I used the PowerShell because I think that was okay. Anyway, so these are the commands you have to type in here. So the first command, I'll just talk about the Windows version here because I know that some people in the class have Windows machines. So when I first installed my Mongo Docker container, I had to run this command here, and this created what's called a volume. A volume, which is the place where I actually stored all my data for my database. Now, what that really means is that when you're storing information into Mongo, it has to have a place to actually store the files. And so this is Windows speak for make a space where the files can be stored. I'm not exactly sure where the files actually get saved. They are there someplace. If you find out, if you're a Windows user and you find out actually where physically the files are located, please let me know. I'd be very interested to hear. Otherwise, once that volume has been created, I typed in this next command here, and what this thing does is it actually runs the container files that we just downloaded. Remember, this is when we did this over here, this is to actually install Mongo in a Docker container. And then this command here, run, says go back and find that container and run the stuff that we found in that, or run the stuff that we downloaded. And so we have this IT, which means interactive mode. So that means you're able to actually work with your Docker and container and type things in and do things. Actually, you get to a command prompt, if you will. Over here is your volume, and your volume is talking about this Mongo data, which we defined up here. So that means if this command doesn't work, then this part here is not going to work. Next, this colon here says that take this volume that's on the Windows system and map it to data /db, which you'll find inside your container. So that means that inside the container, you have those files visible. And that's how it works. They're taking data from the actual Windows machine and putting it through into the Docker machine. Next is the name here. This is what your container is going to be called, MongoDB. And then you have over here Mongo. I think this is the name of the actual. I think Mongo is the name of the. Sorry, this is MongoDB and Mongo. These are the. This is how you actually run this container. But I think that internally you need to know what the command is. I'm not sure exactly what that -d is supposed to mean. But you have to have this here. This is the file name that you'll use to actually run Mongo. So then once we had run that, then we had these commands here, and I'll run this in a moment here. I just want to finish this. But then you run these, and you can actually see whether your Mongo database server is running. That's what this logs is all about. So come with me, if you will, to my login here, where I'm going to go to Linux, and I'm going to type in. I've already done this work here, and so I'm going to just run this next command right here. And that will take me to where I need to go. So hang on, let me just take you with me. Come with me. Where is it? Here, terminal. There. So I'm going to I have my Mongo data directory out here. This is from last time where I have all the stuff that's here. Each time you initiate your Mongo database, you get all these files that show up here. And in fact, let me just show you something. If you type in -h, you're going to get the files that you have are there's a lot of files that end up showing up here, but it's not huge. It's not a huge amount of files that you have to worry about. Having du -h and s, for instance, you have 336K of bytes here, which is about it's I guess it's 336,000. It's about that much space. It's not too bad. And so it's not like you have to worry about erasing these files each time you use them. In fact, I would recommend that you do not erase these files each time you do them, every time you use your database, because these files are your database files. Here you have collection, collection, collection. These may be internal databases that Mongo itself needs to run. And so you'll always find these files showing up here. Of course, the number changes right here, but the database is more or less the same. And that is because you have like internal stuff that Mongo has to do to keep track of its own server. So anyway, you have that there. Now, if I go back to my slides, let's see what's my next command. Ah, yes, next command is going to be this running command here, which is really the same command that we saw when we were working with in Windows. And so if I go ahead and just type that in, oops, actually, maybe I'll do this outside of this directory, maybe inside the MongoDB my Mongo data directory. I'll do this here. Copy that in there, and I've typed my password. Okay, now this meant that everything worked. Now, if you didn't close your Docker container from before, then it's probably still running, and therefore you'd probably get an error message if you were to type in this command here. If you did this run command, you'll probably get an error message here. So if you got an error message here, it probably means that your Docker container is running. In fact, what you can do is you can type in docker, sudo docker, and then you type in ps, and this will tell you what Docker containers are actually running. You can see that I've been running this thing for 25 seconds, which means that it was closed out before, and now it's running. This is your special Docker identifier or container identifier in your, if you ever have to close this container, or if you have to kill this container rather. But we'll talk about that in a second. Going back to my slides, what more do I have? Okay, so now what I need to do is, oh, right. So I'd like to see now what my container is doing. So now it's running. And by the way, when I say running, what do I mean? What do I mean by running? Well, you're running Mongo works by you have a server. And a server is the backbone. It's the information that's actually running. It's actually it's actually running some kind of operations in the background that actually make your queries possible. That's what the server does. It's kind of like a server online. And so when you run this, when you type in this command here, this run command, that opens the container and then it runs the server. So the server is the thing that actually makes Mongo function. So by typing this command here, this docker logs MongoDB, what that does is it says, okay, the container is running, peer inside and tell me what the server inside the container is doing. So it's kind of like the gerbil is in the terrarium, you're opening up the lid and you're looking inside and you're asking the gerbil what he's up to. So this is kind of like how this is working. What are you doing, server? Are you running or not? Excuse me. So all this information here is Mongo speak for yes, I'm running. In fact, this information over here, this should pertain to, for instance, when the database was doing something, when it's something. I'm not really sure what it's doing here. It's listening for something, waiting for connections. That means it's waiting for me to log in with my client and start doing something cool with Mongo. So anyway, but never mind what that is. That's just so that you know that the container actually is running a server. The next thing I can show you is that you want to try typing in, if you want more information about what your container is doing, is by typing Mongo docker ps, and you can see inside. You know, if this were on one line, it's easier to read, but this is on one line. If you open up the window a bit more, but this is again your whole container running with the you can see what's running inside. This means that the container is running. This is a special ID number, and this is what you call it as a human name, if you will. And this is how long it's been since it was created, and this is how long it's been running. So you might find that you have certain containers that have been running for like months. Maybe it's time to stop them. Reestablish that container, or to to download any updates that exist. We're not going to worry about that here because I think this is already. But you have these commands here. One last command that I wanted to take you through, though, before I get to this actual running command, and that is that you have this command right here that stops the container. I'm not going to do that now, but when I have finished using Mongo, then I can just stop the container. Typically, what I do though is I just leave it running. I know that sounds really sloppy, but I just leave it running so that I only have to type in like 1 or 2 commands to actually get back to my MongoDB. But otherwise, I just leave my container running, and then when we finish with working with Mongo, and when you're completely finished with working with this Mongo, for this class, then you might want to think about actually like removing the container or something so you have that. But for now, though, I'm just going to leave it going just because it seems like a good idea. I mean, I might decide to close it later, depending on how much memory it uses up, but I think that it's not too bad. So anyway, and by the way, once you've closed the container, if you wanted to go nuclear and actually destroy the actual traces of the container because you're having some kind of an error, then you can use this command here where you're actually removing the container itself. That means you're actually taking away all traces of it. So for instance, if I type in sudo docker ps minus q minus a, I get the same number here that I got before. If I type in docker rm and then I copy and paste this, which I won't do, but if I have that number in there, then that means after I have to stop it first. I have to stop the container, otherwise it doesn't do anything. But this says go to this container and remove the container. That means to reestablish the container. And I might do that actually if there's an update or if something really wrong happens and I just can't get into the container because of some reason. There is something wrong with the configuration for these files here. I think that maybe there's, I mean, it seems like there must be a better way of doing this. But I think that for now it seems to work okay with this kind of system. But if you are using Mongo though, in a corporate or more permanent setting, then you probably wouldn't want to keep destroying the container as we're doing here. But because this is a demo, then you can do that. There must be there's what I'm saying is there's other code to help you deal with your Docker containers other than destroying it. That's I mean there's a problem with this configuration that it's not designed to long-term. Okay, so finally getting back to here, I'm going to go ahead and just run Docker with my MongoDB. Execute, interactive, execute, interactive. Here's the name of the container, and then get to a bash prompt inside there. So come with me now. Go here and let's run this. I can just type in this, and we're inside root. And so when I'm inside root, if you're running a Linux machine or a Mac machine, it looks very much the same. The only thing that's different here is that you have this root in front of your bash prompt. But if you're running Windows, though, you should see the same thing. It should look exactly like this. Now, one thing I wanted to show you, though, inside the container is you have this area called data. I'll type in ls. This is where your database is stored. Remember these files here? Collection 1 and 2 and 3 and 0, 2, and 4. That's all the information that we saw kind of piped over from my local system. Now it's all visible inside this container, and that is all thanks to this what is it called? Or this command right here. The Mongo data, which is on my hard drive, has now been sent to, or is now being called DataDB inside the container. So I'm able actually to see files. I tell you, I don't know if you guys are feeling this, but every time I do this, I always get goosebumps. Did I say that? I'm getting some nods that I shouldn't be saying that. Okay, I won't say that. But I am getting goosebumps. It's very exciting. Okay, so now let's go back to where we were. So here we are, and now to actually call up my database, I'm just going to type in Mongo, and I am in. And you can type in, for instance, Mongo inside this root, and then you should see something that looks very similar to this. And you can also see, like, for instance, you're running the community version of Mongo, which is just ecstatic news. Very exciting. Okay, so I'm going back now to my slides to see what I'm supposed to do with my exciting new system here. In fact, you have in your slides, by the way, though, you do have all this information in here. So what I'm saying is that if you're running this at home, or you're running this on a different machine, or you're sharing this with your friends, you can share these slides too, because these are the commands that you'd use to actually get in here. And so I'm hoping that later on, like after you're done with this course and you're doing something else that's really, really exciting, you might come back to these slides and type in some of these commands to actually get your system up and coming. Okay, so we're inside Mongo now, and so let's go ahead and just do some fun stuff here. So we have these commands here: show DBS. Now inside Mongo, you have different. You can have different databases. In other words, you can store a different database. You may have a database for your friends, contacts, like friends, names, addresses, phone numbers, etc. You have all that information there. So if I type in show DBS, you have space where you can actually add databases, which are I mean they're actually discrete or different databases. Now this information here, admin config local, you will never touch these things here. These are the actual database, internal databases that Mongo needs to function. I'm thinking that actually what this really means, what this really holds, is information about the server, like when the server was run, by whom, what time, what it's doing, any error messages. You know, it's keeping track of its own logs. So in short, you will never actually be touching any of these files, or those, not these files, but these databases. You just let them coexist. So we have another command here. I can go back here. I can command here. So you'll have DB, config, local. You'll never touch those things. But now, if I type in, for instance, show collections, there's nothing there. In other words, I'm not using it. There's no collection. I haven't started anything. That means that I have no database actually started. So we're going to change that. We're going to go in here, and before we can go any further, we have to say use MyDB, and that's going to be really to create a collection. I'm going to call this collection MyDB, which is, you know, I can call it anything I want. I could say my friend database or something. But if I type in, for instance, show collections now, oops, hang on a second. Show DBS. From here, I guess I have to. Well, it is there. When I first log in, you'll see that it's there. In fact, I'll maybe back out of this and I'll come back inside again. And if I type in show DBS, oh no, I guess it's going to show. Use DB or MyDB. Well, anyway. Actually. Ah, okay. I think that you have to type in show collection here. Oops, not that one. Or DBS. I guess there's no work. Sometimes I'm thinking that you should be able to see your oh, sorry, you can't see the databases yet because there's nothing there. So if I just type in use my, I'll go back here, use MyDB, then for instance I've switched inside this database space, but there is nothing there there's nothing there, and so there's nothing to show. So come with me then back to the slides. Let's do something cool. What we're going to do is we're going to actually enter some basic information in there. Now I always have this command here. If you look at my slides here, but I always have this command here. I'm going to create a greetings table, but before I do that, I'm going to be sure that there's no such table in the directory, or sorry, in the database that exists already. And if there is, I want it gone. And so I have the same command, and I always just put this in here just so I don't forget. But you'll notice that when I type in db greetings.drop, that means database, wake up, look for this database or this collection called greetings, and if you find it, drop it. That means remove it. You always have commands database, wake up. It's basically what that is. DB, wake up. And false means I did not find a database that was there. Okay, good. So I'm going back here, and I'll just put in some basic. I'll just put in one line here. One line. You'll notice that this one line, this part, if you can see this, actually is a JSON file. It actually is a JSON file. That's a JSON formatted. Hang on, so let me just copy this again. I'm going to copy that. Go back to my prompts. Go back here. There we go. And in it goes. Now this is where you have to kind of get used to seeing a different way that the database responds to you. This means this is what you're looking for: number of inserted documents, 1. That's because we only inserted one document here. Now let's go ahead and put something else in there. Let's go back here and I'll put in something goodbye. I'll put in that thing here. This is my other thing. So if I go to copy, and then I'll come back to this terminal, I paste that in there. Again, you'll see that number of inserted things in is 1. And so if I'm copying and pasting, or somehow, in this case, if I'm copying and pasting like 10 different documents, I would expect this number here to be 10. And each document is really this stuff that's surrounded by these things. Now, that's all very interesting. Let's go ahead and put the rest of the information in here. In fact, I wonder if I just copy and paste everything in there. That's fine. So here's 4 things that I'm hoping that I can just dump in there. And if this cooperates, that means no, it doesn't cooperate, because I need to have everything it has to be line by line. Sorry guys, let me just go into line by line. It doesn't work here because there's a formatting problem with my slides. If this were text that I could just use, then it would work just fine. But in this case, it doesn't work. I can't copy and paste things for some reason, and I never find out why that is. So go ahead and just copy line by line if you would, or you can just wait for me to do this, and you can just watch me do the stuff on the screen here. But the database, I'll take you through it in just a moment, is very simple. It doesn't do anything that's extraordinary. It just really has information about common greetings in English, French, and Italian. You can see that I was feeling rather cultural. Okay, so all this information is there. I know that my insertions, every time I've inserted something, I've always got a 1. If I had 2 documents, then I have 2. Well, the next thing I'm wondering is, how do I get this information back? Well, notice that we have these are your basic queries down here. So let's just go ahead and see what those queries do when I put them in. And your query is going to be here. I type in DB, wake up, and then I have my database table that I've been working with is called greetings. Okay, that's important. You need to know that. Oops, greetings. And then I need to have another command here, which is called find. And inside my find, I have these 2 brackets, which I'll just call, they're just going to be empty. But what I do here is you have 2 different kinds of ways of doing things. Here is like your general view here. Everything I want to see would be defined here, and my actual query would be defined in here. So I have to kind of tell it what I want to see, or how I want to see it, and also what the query is that I'm using to actually pull out the information. So let's go back. Let's do a search over here. Oh, one more thing I want to show you is I have this other command where if I type in .pretty, then I can see things as a proper, we call it a JSON file. You can actually see this as a proper JSON file. So try typing this command here. DB, wake up, greetings. I want the greetings collection. And then I want you to type in .find, and that means to find information that exists in there. And then pretty just shows you everything. This is like your select star from table command. It just gives you everything. Now, you can type in some other things here. So if I type in this command here, let me just show you what this thing means. Let me just go back on my slides. You'll notice that every piece of your information you add to this thing here has what's called an object ID. Now, I'm not actually entering that object ID in here. This is all automatically done for me. And you'll notice that it's kind of, there's 76, 77, 78, 79, and so on and so forth. Every number is unique. This is like the primary key that Mongo is actually running for me. In other words, I don't have to worry about the uniqueness of my information. Everything is already put in there, and it's all unique, and it looks, and my primary keys are all instated. So if I run a command like this, this says, I'll just run this here. This is saying, show me everything, but don't show me the ID. And this over here is your ID. And so this is where things get kind of tricky, and it took me some time to kind of swallow this when I first saw this. But in this second part right here, this 0 or 1 would say to show you or not to show you something. So if I put, for instance, 1, that means show me the ID. And if I put 0, it says show me whatever else is there that that's not there.